Welcome to the session. Greeting of the day. In previous classes, we have discussed about the solid state devices. In the solid state devices, we are on the discussions of doping process and then the energy bands, energy gap. So these things we have seen in the last classes. In continuous with that, we have divided the semiconductor into two categories of intrinsic and extrinsic semiconductor. So here we have to see the remaining part in this session. In continuous with the semiconductor of N-type and P-type, we have also connected the PN junctions. We have also connected about the PN junctions we have seen. First we have taken, we know about the silicon, and then from there we have done a doping process to make into the N-type, or otherwise we have converted into the P-type. We know this. And then again we have combined this two to make a PN junction. So we call this as a diode. And then we have tried to convert this by emitting the light source as LED. Right? Now from here we are converting this NP junctions, PN junctions to the transistor. So that is what we are going to see. We are improving the conductivity more from here to there. We are going to use this as a switch, a booster. Okay, such things we are going to do now. We have taken a silicon pure, an insulator. We have added a doping process of N-type impurities or P-type impurities, and then we have done a PN junctions, or we are trying to put extrinsic semiconductors. Intrinsic is silicon is very pure. From there extrinsic doping is done, it become extrinsic. And then NP, PN junctions, we have used it there as a LED, and then the transistor. Now we are going to see about as a process of transistor, a switching methodology. Okay. A transistor is a type of semiconductor. A transistor is a type of semiconductor device that can be used to both conduct or insulate electric current and voltages. So in the transistor, if the boosting is given, it acts as a conductivity, the flow of current happens. If the circuit is reduced or voltage supply is reduced, it becomes an insulator. That we are going to see now. A transistor basically acts as a switch. This is what I am telling. Act as a switch and amplifier. If you are giving more voltage, then it acts as an amplifier. High. If you are not giving, it acts as a switch. If you are more giving, it acts as an amplifier. So that is a control or regulate. So that is we are going to control or regulate those things. A transistor, one of the key component in the most of the electronic devices that are present today. They developed in the year of 1940s and now only recently, this year 1947 by three American physicists of Johnson, Walter and William. See, a transistor consists of PN diodes. We have seen this separately as a P and N. We have done this. Now I am connecting this into back to back. What I am doing, see, I have taken this NP we have already seen. From the NP, I have added one more, and this is a doping process I am doing. One side of silicon I have taken, and then from the silicon, one side I am doping the N impurities, and other side again I am N impurities, and at the center I am doping the P-type impurity. Such cases, what I am doing here, back to back. What is this back to back? I have taken one N, then I have taken one P, and again back to back I have taken one more N. So this one causes one NP junction, and one more, this causes one more NP junction. So there are two are there. So back to back, two I have taken the combination, this one NP junction and another one second junction. We have taken two here. So that is what in this animation also it is shown. So I have taken two. You see, one is doped with N, one is doped with N, one is doped with N, and at center we have doped again with the P, and again here we have doped with the again. So this is one forms one N type NPN junction, and one more I am forming as a PN junction. When the supply has been given here in the forward bias, the flow of current takes place. When on the opposite side it should pull. That is what we have seen in the PN junctions also. We should give more potential greater than 0.7 volt. If it is there, it pushes and comes out. But I am not doing that things here. I am not pushing. I am simply adding one more N-type doping here. In such a way I am forming a transistor. There is the flow of current to make it easy. Anyhow, at these cases it goes. But in the other cases, here also the depletion zone will form. Here also one depletion zone will form. So we have to overcome these things. Here also one depletion zone will form. Here also one depletion zone will form there. So these things we have to overcome. So even though when the current flow takes place at one of the half, as like we have discussed in the NP junction or PN junction, the other half it won't go. There we are adding one more circuit we have to add, so that we are going to see. So here it lets you control the flow of current through the one channel. It lets you what it means. It lets you to control the flow of current through one channel. The channel we are going to add. This is one channel. This one more channel we are going to add in the next images. Okay, one channel by varying the intensity of amount of small current that flow through the second channel. So this is one channel, the main channel you can tell, and this is the secondary channel. When on the secondary channel the flow of current is given as like NP junction, it creates the flow of current in the second channel. So here we can add the bulb. Please observe carefully, we will do. Right. So how I am classifying the transistor into two categories of number one as bipolar junction transistor, and other side where I am telling about the field effective transistor FET, BJT and FET amp. This part we have to see later, and this part now we are going to see in this class. BJT I am again dividing into PNP junction and NPN junction. These are two other types. The working is inverted, that's it, but the functioning is same. See, here I have doped in the three categories of N is doped here, and at center P is doped, and at last I have doped N again. Accordingly we should give the circuit. It will work. But here I am doping P, I am doping N, and again I am doping P. From the PN junction, I am additionally adding one more doping of P. Here I am additionally adding one more N doping process. So here the FET is divided into two categories of JFET and MOSFET. So these things we will discuss. As of now, transistor we are divided into two. One is BJT and one is FET. This BJT again we are divided into a PNP, NPN. This we are going to see now. So now the parts of this transistor. The bipolar junction transistor is a three-terminal device. Of semiconductor that consists of 2p-n junction. We know this. Now this word we know. What is this 2p-n junction? This combination is 1, and again this combination is second one. 2p-n junction. So we can take N-P-n. This is two combinations. This is one combination, second combination, which are able to amplify the signal. It is a current controller device. The three terminals of BJT are bipolar junction transistor. We call this transistor as a bipolar transistor. There are two connections. Bipolar junction transistor. There are two junctions are there. Okay. Now I am telling these elements of number one. There are three elements are there. Number one as a base, a collector, and the emitter. What happens? So this is we can assume this is the image of a BJT device which have three connectors, where I am calling the one as an emitter, one is a base at the center, one is the collector. You see, the three terminals of the BJT in NPN junctions I have taken. First one is emitter. What it does, emitters a charge carriers. It is a charge carrier from where what I am doing. I have connected this connection to the electrical circuit in such a way the PN junction formula takes place here. What formula it is? The electron, when we are connecting to the forward bias, it should repel there. Those formula is taking place in the emitter function. So this will be the emitter and this will be the collector. One is emitter, one is a collector here. So what happens? What happens in the emitter? The electron is emitted from one side. It should receive on the other side, and the current should flow continuously. That's what we are doing. It is a negative lead of the transistor in NPN. In forward bias, this N is connected to the negative side and positive is connected to the other end. So it means here one side is forward bias and other side we are connecting to the reverse bias. Okay, that is what they are telling. It is a negative lead of the transistor. It is the negative lead of the transistor. So I am connecting the connection with respect to one side as negative. This segment is on the left side of the transistor. We know one side we are having a emitter which is on the left side. So this image represents you the same at the left side. So it is moderately sized, a small sized compactly we are doing. So here I am dividing into three segments. One is moderately sized because here we have to do more doping. Doping is nothing but adding of impurities. Here I have added N-type impurity. But how much size I have taken? I have taken the moderated size, but doping is heavy. But doping is heavily doped. Doping is heavily doped to create more charges, maybe the whole in PN junction or maybe the electrons in NPN transistor. In PNP, the holes are majority charge carriers. We know this. In electrons, in the NPN transistor, electrons are majority charge carriers. Whatever it is, we are generally talking about emitter. In the emitter, in the left side, this part is left side, we have taken highly doped of N-type impurities. We have taken the highly doped N-type impurities. Right. Now what I have to do? This electron flow have to take space from this side to this side, and it should go there, and we have to connect to both ends. So what happens? Other end, what we are having here, we have doped with P, right? But we no need this. See, again we draw here, it's the same. So we have N moderately doped, and now we are talking about the P, which is a thin doped. This is used to activate the transistor because we are going to add a circuit here with this. Okay, so that is what we will add it later. This segment is at the center of the transistor. This segment is thin at the center, but we want to travel the electron from one end, from the end to the other end. That is where the flow of current takes place. But here we need this P type to boost, to give the pressure there. Therefore, this segment is at the center of the transistor. Okay. And this is a thin sized. How much we are doing? Here also doped with the P, but it is size is thin. Here it is moderate. Moderate, but it is thin. Right? Again, lightly doped. It is lightly doped with the P. We don't need this. We have to travel an electron flow from one end to the other end, and it should be connected to the circuit. So this is the case. Now we go to the third one. The collector. The collector charges from the emitter. It takes from the emitter. We have the circuit like this, and we have taken N type, moderate doped, and we have taken the P type, which is thin doped, which is a thin doped, which is a thin doped, and it is very thin. Okay, and then again here one more end which is called as collector. So this is emitter, and this is base. So we are going to connect a base circuit here, one more circuit here in the P type in such a way it boosts the electron flow from one side to this side. That is what our needed. So what I am doing here, it is larger than emitter. It is larger than emitter. Here I have sizes is very moderate, P size is very thin, and N size is very large. So likewise I have did. So it is also moderately doped. What I am doing, the N type here it is, I have did more doping, heavily doped. Here it is, P impurities are lightly doped, and at last again N are moderately doped. And it is moderately, because here we need more push. Electron should flow. When it is started to flow, it goes there. There it can be, it is a receiver, it is a collector, therefore size to be large, but dopings are maybe less. But here, doping to be large, it is going to push, so size to be moderate. It is general idea. It is moderate, it is thin, it is just like a pusher, booster. We don't need such a large area in the thin sections. So in the P type. So P is thin, N is moderate, N is large to receive, the collector to be large. It is a positive lead of the transistor. So I told you it is a negative lead, and this is the positive lead. Up to now we have not talked about base. Now we will talk. It means that we have divided the sections of transistor. N, P, N, moderate, thin, large. Doping is heavy, light, moderate. So these 3 points we have talked. So how the base connections is converted to the boosting process, that we have to talk. Now the part is ready. There are two types of bipolar junction transistors as classified in the main list of transistor. Two types we have classified into NPN and PNP. That is the point I have given again here. The PNP, the bipolar junction transistor, NPN, bipolar junction transistor. Among the two, NPN transistor is most preferred for the sake of convenience. Okay, instead of this one, we are going to use mostly as a NPN transistor, as because the electron flow here is high as compared to this one of PNP. So that is what we are highly using this NPN in the most of the cases. So this is a division that the symbol we have to tell at the last. The symbol I will tell you why this arrow is inside the base, why the arrow is outside the base, that we will understand. Okay. So here also the emitter, base collector for PNP, and then NPN, similarly emitter, base collector. But you can see in the PNP the image is inverted, that you should understand. Okay, we are told the emitter is left, but in this image we are showing emitter is the right side. Please understand. The PNP, first P is emitter, again the second word N is base, again the P is collector. Here we are boosting, B for boost. Okay, so again here also NPN, N is one first initial N is emitter, again the P is base, again other end N is collector. Here it it should send and it should receive and it should be connected. And circuit should close. That we will see now. The symbol I will tell at the last. It's easy. Right. In Npn Bjt, I have taken, both are same. I told you PNP, NPN both are same. I have taken an example of NPN for our case. Here, a p-type semiconductor is sandwiched between the two n-type. A simple word you should understand. The p-type semiconductor is sandwiched between two ends. Okay, it's sandwiched between two n-type. One n-type, second n-type. Okay, the p-type semiconductor act as a base. This also we know from the previous image. We understand the center part act as a base, while the two n-type semiconductor act as a, one is emitter, one is the collector. It means the left, for our case, here it is emitter and here it is a collector. So left is the emitter, right is the collector for our case for NPN. If it is PNP also same, N will be at the center, P and P will be at the two ends. It is sandwiched like that. That image also you see. So what I have did here, you see, I have taken a 3 layers. We understand now the concept we are coming. We have taken the 3 layers. We know the function of the PN junction. When we are connected this type, this is P and this is N, and I am connecting in the forward bias. It means N is connected to negative and P is connected to the positive. So when I am connecting this like this cases, these electrons we are pushing here, it ripples there. The rippling process takes place in this zone. Therefore, the electrons here are attracted towards this point. Because of repulsive force given, they are attracted towards the junction point. And when we are giving greater than 0.7 volt, this push happens and then these electrons are crossing this depletion zone and goes that side. Then what happens? Here we have positive. This is negative. Here we have positive. If it is here, it is positive. Automatically, these electrons are absorbed and it flows. This we know from the PN junction. So now what I am doing? Now what I am doing here? I have taken similar pattern of N and P. Here we have another N. Okay. So what I am doing here? I want to make a fast flow here because this we have pushed. Okay, we have connected to the forward bias and 0.7 volt is given. It is pushed now. Repulsion happens, but here it is crossed. But there, when it is crossed again, one more depletion layer I am making to make it as a switch here. Here there is no switch. 0.7 is directly given, it activated, it goes there. I want to make it as a switch. So the P is there. This is lightly doped, heavily doped, moderately doped. For our case, for technically, it should be moderate, thin, and large size because it's a character. We know this. Okay. So okay. So now I want to act as a switch, a booster. What I am doing here, 0.7 it went inside, but again here also one depletion zone is there. Here also one depletion zone is there. So you have to cross this zone. What I am doing, I am connecting here on one more connection. One more connection I am doing here. So what happens? This is I am connecting to the positive. Right? I am having one more battery here. A secondary connection. What happens? The electrons are received. Here we have electrons. It is pushed, repelled there and comes here and absorbed by the positive. Right? And then it started to flow. And the circuit is closed here again. Right? Now the flow started. Okay? When here more charge has been given for attraction, it absorbs more. It keeps on observing more. It keeps on observing more. Then what happens? It can flow through one point, right? But the rippled access to 0.7, here it is, electrons are more. It generates more electrons here. It generates more electrons here. It is accumulated by this force of base. By the force of base given. But it can absorb lightly. But the receiving is more. It gives, it is attracted there, but it is receiving a small battery. It considers a small battery. They have given the connection and the absorbing link has been given. It is started to absorb to the P, but it is inside it is receiving is very small. But the emitter electrons are accumulating in the thin layered P-type doping positive. Now what happens here? A pressure is generated. Because more electrons are generated, it is also become greater than 7. It will also become greater than 0.7. So what happens then if it is greater than 0.7? Automatically this depletion zone will arise. Automatically this depletion zone will arise. So what happens then? If it is erased, so this electron can flow. This electron can flow here to here. This electron can flow from here to here. Then we have positive here. You see, here we have positive already. So that we can able to connect again and the circuit closed. Now when the base is disconnected, automatically this circuit of force will not take place. Then automatically the circuit will disconnect. When the force, the base is given again, here the 0.7 is generated and goes again. So that is what a simple understanding. See here, I have connected the two connections. This is P, NP junctions I have taken. I have taken this NP junction. Here this is N and this is P. The flow of current takes place here. See, the flow of current takes place. The base, the positive, negative. Here also forward junction, N and P. Here the electrons move. Here it moves. But here it is cumulated at this point. At this point it is cumulated. When it is cumulated, see, circuit is running. The circuit is running. Small one end, a battery is going. The remaining part, the remaining electrons are accumulated and this breaks the depletion zone in the other end. Here one depletion zone is there. Here one depletion zone is there. Here automatically it breaks. Here due to this battery, we are going to break this second depletion zone. And due to the second depletion zone breaking, we can able to cause the flow of electrons throughout the battery setup. See, first power source and this is the second power source. The base acts as a booster, maybe as a switch. The voltage between the base and emitter, a positive at the base, negative at the emitter. So that's how we have connected and we can able to. So from this image we can understand the same NPN I have taken. One is emitter, connector and the base. Right? I have connected similarly N to negative and the P to the positive I have connected. Right here the flow takes place from positive to negative. How it takes place? The flow takes place usually positive to, current flow will be positive to negative. Therefore, this takes place from this side to this side. So from where to where it goes? From base to the N it goes. It means emitter. Base to the emitter it goes. Therefore, I am drawing this symbol of Npn Bjt as base to emitter. The arrow I am putting in this forward. Base to emitter I am putting. So one end is collector. So the arrow mentions the current flow from base to the emitter. So this image, one is forward bias, one is reverse bias, NPN. Similarly, when we are inverting this PNP functions, this also reversed. When the P comes there, automatically the forward bias, this becomes positive. So the applications of amplifying process, oscillating, acting as a switches. I want to play a video clip here.
We opened on the scene inside the toy cars and the remotes, we could have seen a board which contains a lot of transistors. It is widely used in all types of electronic devices like sensors, circuits, phones, TVs, planes and even in the induction stoves. Simple phone generally we have more than 40,000 transistors. These transistors do a simple job of as like normal switching on and switching off, but with respect to supply of current, we no need to operate physically. It is like an automatic electric switch. If we want to use a normal switch for every applications like camera, torch and everything, the phone will be like a big house. This transistor is made up of a semiconductor. When we touch the camera app, the transistors come into the closed circuits and activate the transistors which started to give the action. To understand the concept of transistor, we should go back to atomic level functions. In one region, the silicon contains 4 electrons and phosphorus contains 5 electrons. In another region, the silicon contains 4 electrons and the boron contains 3 electrons. The region 1 contains a high electrons which we name as negative, that is N region. The region 2 which contains less electrons which we name as positive, that is P region. On the boundary, the extra electrons from phosphorus will attracted by boron and the boundary layers will have equally 4 electrons each. This zone is known as depletion region. Now the n-type boundary become positive as it is donates electron. The p-type boundary become negative as it accepts electron. When we connect a battery and build to this NP semiconductor forms, the electron will flow from battery towards the N region when connected in a forward bias. But when this electron reaches negative depletion zone, it repels and comes back. So circuit not closed and bulb will not on. To make so the bulb on functions, we should send electron flow greater than 0.7 volt. If we send like that, the electron flow will break the breakover voltage and electron flow will happen. So bulb will on. Here the PN circuit have not act as a switch. When we simply supplied a voltage greater than 0.7 volt, it activated. To make it as a switch, we should add one more negative region, but on that one more depletion region will also form. So again electron flow will be stopped. To convert as a switch, we should add a base circuit from positive of the battery to the P region. If do like this, the electron already following in the first N region will come back to the battery through this extra connected circuit. In this situation, in P region, more electrons will accumulate and so an extra push is generated. This push creates the electron flow to N region and to the bulb and connects the circuit to on. We understand that only when a base circuit is connected to P region, the battery and the bulb ons. If the base circuit is disconnected, the extra push won't be there, so bulb won't on, it will be in the off position. Now this transistor acts as a simple switch, we understand. Now let me compare this setup with the phone. We replace the bulb with a camera and we add a touch sensor between P regions and the battery on the base circuit. When we touch corresponding torch app, the circuit closed and electron flow happens and the switch on the torch. In the transistor, the left region is emitter, the right region is a collector and the center region is the base. In a real-time transistor also, the left region is an emitter, the right region is a collector and the center region is the base. Now we came to know about the transistor works. Let me go back to know what they used in the olden days before the transistor is invented. Let me go back now. In 1944, the World War II in US, the scientists worked on Manhattan project. In this project, they prepared a computer named as Harvard Mark I. This computer used to calculate how much damages will be there by this atomic bombs. In this computer, instead of this transistor, they have used an electromechanical relay. In this electromechanical relay, there are two rods and there are one at the bottom, one at the top over the other. When these two rods are connected, the current circuit will flow. To make connected, they activated an electromagnet which in turn activates the rod and the circuit will close and current flow takes place. When electromagnet is off, the circuit will disconnect again. As this relay size is very big, the computer size also become very big and the failure rate also increased because of the moving part. To solve this problem in 1947, three scientists worked together to found a transistor and they got a Nobel Prize for that also. Let me make a simple on-off room automatic sensor with these understandings. In this setup, we have taken one pyroelectric infrared sensor, one transistor, one battery and one electromagnet which is connected to a electromagnetic relay and it connecting to the bulb. Now, when a person enters the room, the infrared sensors will sense and sends the output to the transistor. Now, this transistor will act as a switch and closes the circuit to activate the relay to on the bulb which is in the another circuit at the top. So that is how a very simple a bulb can be on.
So the summary, we have discussed today about the BJT, bipolar junction transistors. In that we have talked about NPN and the PNP, which is a reverse format of this. When it is a forward biased current flow, when it is reverse biased, no current flow. Okay. So it is a reverse format of that. So remaining part of the subjects we will see you in the next session. Thank you.